All right, now we're going to talk about linear regression. This kind of stems right off of scatter plots. So in the last section, we talked about scatter plots, and actually, I'm going to back up just a minute and show you that in the last example, which I finished here, to figure out which one was the best answer, we went through and drew the line for each equation given. Well, with linear regression, the section we're going to do today, we are not giving equations to look at. So with scatter plots in the last section, we were actually given equations and we just had to choose the best equation. Now I'm going to show you how to use your calculator to find an equation if you're not given one. So linear regression is the method used to find a line of best fit. All right, you can do this by using your graphing calculator using these steps provided. All right, so if you have a TI-84 plus, that's usually what we use for state testing, etc. If you have a TI-84 Silver Edition or whatever, even a TI-83 is a little bit older model, but it should work. Okay, so these steps should work for any TI-83 or 84 calculator. And if you have questions, you can ask me. All right, so let's go through and look to see how you can use your calculator to write an equation. All right, when writing an equation, you're going to use the steps above like we just talked about, but the first thing I'm going to have you do is clear your list. So again, if you have a TI-83 or an 84, this is going to work. So to clear your list, meaning if there's already points in there, you need to get rid of those so that you can put new points in. So to clear your list, you're going to hit second plus and number 4. Okay, second plus 4. That'll clear the previous table out if anybody's put a table in there. All right, now hit stat and enter, and that's going to give you a right to edit your list. So you're going to put your X's in L1, so that's going to be your latitude, so these are going to be your X, and then you're going to put your Y's in L2, so that will be, in this case, the temperature. Now you do need to make sure that when you're given a table that you have the same number of X's and Y's. These are like ordered pairs, so it's very important that you have the same number of X's and Y's in your table. So take just a second, enter your numbers in your table, and then hit resume when you're done. All right, hopefully now you have your numbers in L1 and L2 in your table, and so now you're going to hit stat again. This time, instead of edit, you're going to arrow over to the calculate button. That's going to be the one in the middle across the top. You're going to see that. You go over to calculate and you're going to choose the linear regression. Remember, linear is a line and linear regression is the process of using your calculator to write an equation for you. So choose number 4 and it's going to give you an A and a B. And if you look right above that, it says y equals AX plus B. So in your calculator's mind, A is your slope and B is your y-intercept. So for this equation, and you do have to round these a little bit, so I'm going to put negative 1.07, and it has A, but we use X typically, so I'm going to use X because we use X and Y a lot. So negative 1.07X plus, and then my y-intercept is going to be about, it says 92.86, and it keeps going, so I'm going to put about 93. Okay, so again, this is not the exact line for each of these points. This is going to be the best fit line. Okay, so this is a line that represents the best fit for this scatter plot. All right, so the B part says estimate the average temperature for the city with a latitude of 48 degrees. And remember we said latitude is our x's. So we're going to say y equals negative 1.07. And in place of x, we're going to substitute 48. And then when we plug this in our calculator, negative 1.07 times 48 plus 93, we get about 41.64, about 42 degrees. So that would be about 42 degrees in Fahrenheit. So that gives us Fahrenheit here. All right, we're going to look at another example. First, don't remember how to clear out your table. So second plus number 4 will clear out your table from the last example. All right, so go ahead and put in your new table. So go to Stat and Edit, and let's put in passengers for L1 and suitcases for L2. All right, again, make sure that you have the same number of x's as you do y's. Also, always double check to make that your numbers are entered correctly. If you don't have your numbers entered in your table correctly, your calculator cannot write the correct equation. This is an easy process to write an equation for your line of best fit, but it's only as accurate as the information it's given. So make sure that each number is entered correctly, that you don't transpose numbers or miss a number or just, type it in incorrectly. All right, hopefully you've had time to put these in your table. So go back to Stat, arrow over to Calculate, and then you're going to click number 4 again to find your equation. So again, we're going to do y equals. This time it says our slope is 1.97966 or 969945. So I'm going to round that to 1.98. And then I'm going to use x, and then I'm going to have a y-intercept of 7.966, so let's do 7.97. There's no exact number of places that you need to round it to, but if you're not sure, the hundredths place or 2 decimal places is a good place to round to. All right, estimate the number of suitcases on a flight carrying 250 people. 250 people is the number of passengers, which is your x. So we're going to have y equals 1.98 times 250 plus 7.96. And I'm going to get about 503 suitcases. All right, number 3 says the data in the table below shows the number of graduating seniors at Cannon Valley High School since 2012. Okay, so this is important. So they're saying since 2012. So instead of putting the year, to get the correct line of best fit, we have to change the years to what makes sense. So since 2012, 2012 would be year 0. And then this would be 1 year after 2012. This would be 2 years after, 3, 4, and 5. So this time in your table, you're going to put 0 through 5 and then put the numbers for graduates. So go ahead and take a minute to do that, and then we'll look at the equation. All right, hopefully you've entered your numbers. You've double checked to make sure you entered them correctly, and then you went ahead and found your equation. So if you did that, you should have went to Stats, Calculate, Linear Regression. Our slope is about 9.17, and our y-intercept 338.24. All right, now it says estimate the number of graduating seniors in 2025. So remember we started in 2012. So how many years is 2025 from year 0? So that would be 13. So we're going to take our equation, y equals 9.17. We want to know 13 years later. What's going to happen? So you're going to take this and substitute the numbers in and then get all right, so you're going to get around 457.45 graduates. Since graduates is talking about a number of people, we're going to round this to about, these squiggly lines mean rounding, so it's about 457 graduates or people. So you can't have a fraction of a person. All right, the table, or the data in the table on the left shows the Olympic 500-meter gold medal speed skating times. All right, so it doesn't tell us to use 1980 as year 0, but let's use 1980 as year 0. It's just smaller numbers and easier to put in your table, in your calculator. So if 1980 is our starting point, that's going to be year 0. 84 would be 4 years later. 88 would be 8 years later. 12 years, and that's when we have the Olympics, is every 4 years. So that's why we're going by 4s here. All right, so take a minute, pause the video, go ahead and put in your X's or L1 for year, and put in your times for L2 or your Y values. All right, hopefully you found your equation. So we're going to put y equals negative 2 0.11x plus about 430.24. All right, so estimate the 500-meter time for the 2020 Olympics. So 2020 is how many years past 1980? So that would be 40 years. So we're going to plug that into our equation. And then when you solve that, you're going to get y equals 345.84. So that would be our time, the estimated time in seconds for a gold medal speed skater in the 500 meters in the year 2020. All right, the data in the table on the left shows sales for a certain department store in billions of dollars. So go ahead and put these numbers in your table, and then we're going to look at what the equation is. So I used 0 to start with just because it makes the numbers smaller in your table. You can do that if you like. All right, y equals 16.46 x plus 217.52. All right, the estimated sales in 2018, 18 plus 6 years from 94 to 2000 is 6, so that would be 18 plus 6 is 24. Y equals 16.46 So substitute 20